Hello and welcome to my science tutorials. In today's video we are going to be looking at projectile motion. So before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics and physics. So let's begin. So what is a projectile? Well, a projectile is a particle which has an initial velocity and then it moves freely under gravity. So we have a projectile motion when a particle is projected at an angle to the horizontal and hence making the particle to travel in a parabolic manner. What do I mean by this? Let's consider this diagram. So if this is our Cartesian plane, and then this is our origin, this is our x-axis, this is our y-axis. If we have a particle being thrown into the air with an initial velocity of what, u, the particle will go up, and then as it reaches the maximum height, then it will turn and then come down. So this is what we mean by what, a parabolic manner. Now the greatest height over here is what we call the y max or h. That is the greatest height that the particle will reach before it comes down. Now this initial velocity that the body has is what is into two parts. Okay, so we have the horizontal part and then the vertical component of this velocity. So we have the y component, okay, which is what, uy, or which is what, the vertical component of the velocity, and then we have what, ux, which is what, the horizontal component of this velocity. Now when we want to look at the formula or the equations that we use in projectile motion, we need to consider what, the vertical component of the initial velocity and then the horizontal component of the initial velocity, and use it to make deductions before we can be able to do what, any calculation on projectile motion. So I'll first of all like for us to code down the formulas of what, equations of motion, so that we use them in deriving the equations that we need for our work. So we know the first formula for our first equation of motion is what, v is equal to u plus what, gt. And we have the second one, v squared is equal to u squared plus what, 2gs. And then we have 3, our height or h is equal to what, ut plus half gt squared. All right, so let's look at the horizontal component of this motion. So the horizontal component. Now for the horizontal component, the only thing we can see here is that what, our velocity, which is ux, will be given to us because the particle is projected at an angle alpha. The horizontal component of this will be what, the velocity cos the angle. That will be what, the horizontal component of this diagram we have over here. Now as you can see, the particle moves up and then comes down. So you can see that the only thing that the particle does that we use the horizontal component is what, the distance traveled from, let's say, the point of the origin to this point here, a. That is the only thing that is horizontal about this diagram. But all the other things are sort of what, vertical. So we'll be using what, the vertical component of this diagram more to do calculations. So let's look at the vertical part. So the vertical component. Now the vertical component uses what? For the vertical component, our initial velocity, which is what, uy, will be given to us by what, u sine alpha, or the angle. So if this is true, all we need to do is what, substitute our uy over here, which is the vertical component, into what, into the places of u that we have over here, and then we have what, our new set of equations for projectile motion. So let's go ahead and do that. Now mind you, the particle is going up, and if you are going up, you are working what? Against gravity. So what? Our gravity becomes negative instead of what? Positive, as we see over here. So this whole formula for projectile motion can be rewritten as what? Vy, which is what? The final velocity, is equal to the initial velocity is what? Uy, or just u, sine alpha minus gt. Then we have what? Our final velocity square again, Vy squared, is equal to what? U, which is u sine alpha, the initial velocity over here, squared, minus what? 2gh. Then we have the final one, which is h, or the height, is equal to what? The u, which again is what? U sine alpha t minus half gt squared. So these three equations are what we use in what? Solving problems on projectile motion. Now let's have some little deductions from this equation before we go ahead and solve some examples. So the first deduction we want to make is what? The time for flight, or time of what? Flight. Now for the time of flight, we are considering when the particle starts moving and then where it has ended. Okay, so we want to use the final equation we have over here, which is what? H is equal to u sine alpha t minus half gt squared for our deduction. Now if we look at the whole scenario that we are trying to describe, the time of flight will be what? When the particle starts from rest and then when it has ended. Now for that to be true, it means at point A over here, our maximum height will be 0. Okay, the maximum height is 0 because what? The particle has gone up and then it has come down. So at this point, which is the time that it has taken to complete the flight, we do not have the particle at a higher position but on the ground, so we don't have maximum height for it. So our height here, h, is equal to 0. So if our h is equal to 0, it means the whole equation we have over here can be rewritten as what? U sine alpha t minus half gt squared is equal to 0. So if we bring this side to the other side of the equal to sign, we have what? U sine alpha t is equal to what? Half gt squared. So we multiply through by what? Half, to get rid of the half we have over here. So we have 2 u sine alpha t is equal to what? Gt squared. Now let's bring it back. So we have 2u sine alpha t minus what? Gt squared is equal to 0. Now we can see we have t common in both equations, so we factor the t out. So we have what? T outside, then into brackets u sine alpha, 2u sine alpha, then minus gt. This is not supposed to be here. Alright, so if we factor t out from here, this is what we get, is equal to 0. So from here it means what? This t over here is equal to 0. The t is equal to 0, or the whole of this in the bracket over here, 2u sine alpha minus what? Gt is equal to what? 0. So if we simplify what we have over here being equal to 0, what are we going to get? We get what? 2u sine alpha is equal to what? Gt. So we divide by g, and then we get our t, which is what? The time for flight in this case to be what? 2u sine alpha divided by g. So this is the equation that we use to find the time of flight if the question asks us to find time of flight. So don't worry about the process that I go through to discover or to derive the formula. All you need to know is that what, when you are being asked for the time of flight, the time of flight is equal to what, twice the initial velocity divided by what, the gravity. And we use what, sine the angle that the particle has been projected at. Let's have a look at what the range. How are we going to calculate the range? Now mind you, the range is the distance what, OA over here. That is the range. So let's look at that deduction. Now the range, okay, or the what, the horizontal component of that, the range. Let's look at this. We have velocity. We know velocity is equal to what, distance or what, the range over time. And then the time in this case, because we want to know the distance from O to A, the time is what, the time for flight, which is what we have over here. Now if we cross multiply, we can see that the range is equal to what, the velocity V times the time. Okay, now we know the velocity is what, our ux, and then our time is what, the time for flight that we already saw in the previous deduction. So if this holds true, then we can calculate our range. Now mind you, the range, let's look at this diagram again. The range has to do with what, the horizontal component. So we use what, this as our u. So we use the ux is what, u cos alpha. So let's go ahead. So we have our u to be what, u cos alpha multiplied by the time for flight is what we have over here, which is 2u sine alpha, all divided by what, g. So we substitute that, and then we have what, 2u sine alpha all divided by g. So if we expand what we have in the bracket over here, we are going to get what, 2u squared cos alpha sine alpha all divided by g. Okay, so let's rewrite this. We can have what, u squared here, then we have 2 sine alpha cos alpha divided by g. Now from trigonometry, okay, we have something we call what, sine 2 alpha, and this is, if we expand this, we get what, sine alpha cos alpha plus what, cos alpha sine alpha, which are this, they are all the same. Multiplication is commutative, so we have what, 2 cos alpha sine alpha, which is the same as what we have over here. So in place of everything we have over here, the 2 sine alpha cos alpha, we can bring sine what, 2 alpha in place of this. So it means our range is equal to what, u squared what, sine 2 alpha divided by g. So this is how we compute for our range, if in case the question asks us to find the range. So you just use what, the initial velocity squared sine 2 alpha, the angle, then you divide it by the gravity, and then you get what, your range. So this is our equation 2. This is very, very important. This is our equation 1, and then this is our equation 2. Let's note them down because we are going to use them in solving practical examples. So let's look at how we get our what, maximum height. Our maximum height. Now for our maximum height, we are going to use the formula this. So we are using V is equal to u sine alpha minus gt. Now at the maximum height where we have, let's look at the diagram again. At our maximum height, okay, the particle only has what, initial velocity, and does not have what, final velocity. So it means at the maximum height, our Vy here is equal to what, 0. So if that is the case, it means we can rewrite this as what, 0 is equal to what, u sine alpha minus what, gt. If we make gt the subject, we get what, u sine alpha over here. So we get our time over here to be what? U sine alpha divided by what? G. So this means this is the time, okay? This is the time it takes the particle to reach the maximum height. Let's note these two as well as equation 3. Now, if this is the time it takes to reach the maximum height, then if we put this time it takes to reach the maximum height into the formula, h is equal to what? Ut minus what? Half gt squared. The u here is the ux, so it's equal to what? H is equal to what? U sine alpha. Then the t is the time that we have over here, so it's what? U sine alpha again divided by g, then minus half g, then the t again, which is what? U sine alpha divided by g, all squared. So let's simplify this. So if we simplify this, we get our height to be what? U squared sine square alpha divided by g minus half g u squared sine square alpha, all divided by what? 2g. Sorry, g, there's the g over here. Okay, so if we further break this thing down and we simplify everything we have over here, we are going to get what? 2u square sine square alpha minus what? u square sine square alpha divided by what? 2g, if we simplify what we have over here. So it means what? If we look at this, we can see that we have u square sine squared alpha, we have twice that over here, twice u square sine square alpha. So we can say what? If we subtract this from this, we are going to just get what? U squared sine square alpha all over what? 2g. So this is the formula that we use to get what? Our what? Greatest height or the maximum height for projectile, in case we are being asked to find that. So let's go through all the deductions that we've made so far. So we said what? The time taken or the time for flight for a particular projectile motion is given to us by what? 2u sine alpha divided by what? The gravity, which is what we have over here. Let me use another color to indicate that. Let me use red. So this is our equation 1. So this is the time for flight. Now if we are being asked to find the range or the distance that the particle or the projectile has covered after it has landed from the initial point to the final point, we use what? U squared sine 2 alpha divided by g as our range, or what? The horizontal distance covered by the body. Then we went ahead to find what? The time taken to reach the maximum height. So this is the time taken to reach the maximum height. And then this is what? The formula that we use to calculate what? The maximum height, or h max. So with these 4 equations that we have, let's go ahead and solve some examples. So example number 1, and it reads: a particle is projected from the ground level with a speed of what? 30 meters per second at an angle of 30 degrees to the horizontal. Calculate I, the time for flight, II, the range, III, the time taken to reach the greatest height, and then IV, the greatest height. So beautiful. So let's dive in. So let's write our solution. So first of all, we need to draw the diagram or try to picture what the question is trying to tell us before we go on. So they said a particle is projected, okay, from the ground level with this speed at an angle of what? 30. So if we draw our plane, okay, so it means the particle was thrown with what? The velocity of what? 30 meters per second. So this is our uy, our ux. So let's say the particle has made the parabolic turn like this. So this is our O, this is our A, this is our h max or maximum height. Okay, All right, so if that is, or this is our diagram, and then the angle is what, an angle of what, 30 degrees, an angle of 30 degrees. So let's go ahead and see how we can solve this. So I so our I, the time for flight. Now we know time for flight from the deductions we made earlier is what, t is equal to what, 2u sine alpha divided by what, the gravity. So our time for flight t is equal to what, 2, our u initial velocity is what, 30, so we have 30 sine, the angle is what, 30, then divided by what, gravity. So if we compute this in our gravity is 10 over here. So if we input this into the calculator, we are going to get our time to be what, 3 seconds. So let's go ahead. Now let's find the range. The range r, as we saw earlier, is what, u squared sine 2 alpha divided by what, gravity. So this means we have what, 30 squared sine 2 alpha, which is what, 2 into bracket 30, all over what, 10. So this is equal to, if we input this into the calculator, or we have, let's say 30 squared sine, this is what, 60 divided by 10. So our range, okay, is going to be what, 77.94 meters. So this is our range. So the distance, what, OA, or the range, is what, 77.94 meters. So let's go ahead. I, the time taken to reach the maximum height. As we also saw earlier, the time taken to reach the maximum height is what, u sine alpha divided by what, gravity. So we have what, 30 sine 30 divided by 10, and this is going to give us the time of what, 1.5 seconds. So the final aspect, the greatest height, or the maximum height, which is the h max, as we also saw earlier, is what, u squared sine squared alpha divided by what, 2g. Okay, so this means we have what, 30 squared sine squared 30 divided by what, 20. And then our maximum height, if we input this into the calculator, we are going to get what, 11.25 meters. So this is the first example. Let's look at another example to further enhance our understanding of projectile motion concept. Now, example number 2, and it reads, a stone is projected upwards at an angle of what, 30 degrees to the horizontal from the top of a tower of height 100 meters, and it hits the ground at point Q. If the initial velocity of the projectile is what, 100 meters per second, calculate the I, maximum height of the stone above the ground, II, time taken to reach this height, okay, then III, time for flight, and then IV, horizontal distance from the foot of the tower to the point Q, or simply the range. We neglect air resistance and we take our gravity to be what, 10 meters per second squared. So let's dive in. So we write our solution. Alright, so first of all, we need to draw the diagram so that we can see what is going on over here. So we have a stone is projected upward at an angle what, 30 to the horizontal from the top of a tower. And so if this is our tower, let's say this is our tower, so the particle is being projected from the top of the tower and it moves down and hits the ground at a point what, Q. So this is, don't mind, this is not drawn to scale. So this is our tower. Now they are saying the tower is what? 100 meters high. So that is the height of the tower. So this is more like what the projectile has gone through. So this is our H mass, assuming this is our what? Our horizontal. Okay, so the initial velocity for this projectile, okay, is not drawn to scale, so let me assume this is our initial velocity. So our initial velocity is what? The angle here is what? 30, and then our initial velocity given to us in the question is 100 meters per second. All right, so let's go ahead and tackle the question that we have. So the first one is saying we should get the maximum height of the stone above the ground. Above the ground. So first of all, we need to what? Find the maximum height of the stone above the ground. So we need to find the H max over here. Then we add it to 100 to get what? Our maximum height above the ground. So we see our height. First of all, our height, or the H max, the normal H max for the projectile, assuming this is our horizontal, is equal to what? So we go ahead, let me use this. So we have final velocity squared is equal to what? U sine alpha squared minus what? 2gh. So we know at the maximum height our final velocity is 0, so we have 0 is equal to what? 100 sine 30 squared minus 2 into bracket 10h. Alright, so if we punch this into the calculator, we are going to get what? 50 squared minus 20 what? H. So if we send the 50 to the other, or the 20 to the other side, we get 20h is equal to what? 2500 from here. So we divide by 20, we get what? Our height to be equal to what? 125 meters. So it means the height, okay, of the projectile itself, assuming this is our horizontal, is what? 125. But now the height, okay, or the maximum height, okay, from the ground is now what? The H max over here plus the 100 we have over here. So we have 125 plus 100, and then this is what? 225 meters high. So the height from the ground is what? 225 meters high. So let's go ahead and look at what? The second aspect, the time it takes to reach this height, or what? Time it takes to reach the maximum height. So the II, time taken to reach the maximum height, the same, we use Vy is equal to what? U sine alpha minus what? Gt. Now the time taken to reach this height, we know the final velocity is 0, so we have what? 100 sine 30 minus what? 10t. So we bring 10t to the other side, we have 10t is equal to, now 100 sine 30 will give us what? 50. So we divide all by 10 by 10, so we get our time to be what? 5 seconds. So the time it took the particle to reach what? The maximum height is what? 5 seconds. Now let's look at the others, the third one, the III, which says what? Time for flight. Alright, so the time for flight in this case will be what? The time for flight will be what? Let's look at that. Now let's first of all find the time it took, okay, the time for flight itself, that is, sorry, time for flight, which means from here to here, that is the time of flight, and then we look at the time it takes for the particle to come down, and we add the two of them. Sorry, so that will be equal to what? We are using the formula H is equal to what? U sine alpha t minus half gt squared. Okay, so this is plus, and then at the maximum height we have our initial velocity, or the time for flight, u is equal to 0. So we have our h, okay, which is the what we already calculated over here, which is 225, the maximum height. So we have 225 over here is equal to what? 0. This is 0 plus half 10t squared. All right, so if this is the case, we just go ahead and then solve for t. So we have what? This is 225 is equal to half of 10 is 5t squared. So we divide by 5, then we have our t squared is equal to what? 45. So if we take the root of 45, we have our time to be what? 6.71 seconds. So time of flight, okay, will not be equal to, remember we calculated the time, okay, taken to reach the maximum height over here is what? 5 seconds, and then the time for the whole flight is what? 6.71 seconds. So we just add the two, which is what? 5 plus what? 6.71 seconds, and then we get our total time to be what? 11.71 seconds for the time of flight for this particular projectile. So now let's look at the final aspect, which is what? The horizontal distance, or the range. So for the range, we have our range to be what? The velocity, which is ux, or u cos alpha, times the time, or the time of flight. So we have the u is already 100, so we have 100 cos 30 multiplied by the time, which is what? 11.71 seconds. So we have our range to be what? If we input this into the calculator, we are going to get 10,014.1 meters. So this is how we solve problems on projectile motion. Thank you so much for watching, and then I'll see you in the next video. Bye bye.